Welcome to the RCSI Cardiovascular Society ECG Basics tutorial. What we'll be doing today is going over our approach to general ECG interpretation that we'll be using in each subsequent tutorial. In those tutorials, we'll move quickly through the interpretation, so if you'd like a more detailed explanation for any of those rhythms, come back to this video to see detailed explanations of every step. In a normal ECG, we have these 5 main features. It's important to understand that they're not just electrical activity, but are often associated with mechanical activity of the heart. The Pwave, representing atrial contraction, the PR interval, the delay going across the AV node, the QRS complex, which is ventricular contraction, the QT interval, an electrical quiet period, and the ST segment, which is ventricular repolarization. Here you'll see our systemic approach to ECG interpretation. What we'll try and do in every subsequent tutorial is follow this set of steps so as not to get lost or confused, and to really set down a methodology that you can take with you in any setting when doing ECG interpretation. Starting with rate, all ECGs have a rate and can be characterized as bradycardia, tachycardia, or normal. Bradycardia being below 60, tachy being above 100, and normal being between those two. For rate, we have 2 main methods that we use. The 300 method is a quicker way that you can use, but you have to make sure that the rhythm is regular. And we'll get to that in a little bit. We'll start with the 300 method. And what you do here is find an R wave that lands on the edge of a big box and count how many big boxes until the next R wave. So there's 1, 2, 3, 4, and 5. You take that number and you divide it into 300. So 300 divided by 5 is 60, 300 divided by 4 is 75. And you know your rhythm is between those 2 numbers. Let's try it on this example right here. This one's pretty close. So here is 1, 2, 3, 4. So it's between 4 and 5 big boxes. 300 divided by 4 is 75. 300 divided by 5 is 60. This is closer to the 75 side, so we can call this about 75 beats per minute. Now this method breaks down when you have an irregular rhythm, because it depends on the space between each R wave. In this case, if we use the 300 method, these 2 R waves would give us 300 divided by 1, 2, 3, 4. So we'd think 75. If we did the same thing here, 1, 2, 3, 4, 5, 6, 7, 8. So we'd get something closer to a heart rate of 20 or 30 beats per minute. So clearly this method doesn't work. The solution here is to use the 10-second method. You find a rhythm strip, you count how many beats are in that 10-second strip, and then you multiply that by 6. So let's take our previous example. This entire strip is 10 seconds long, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 6 is 72 beats per minute, and that corresponds pretty closely to the 300 method we did previously. So, when in doubt, use the 10-second method, but if you know that the rhythm is regular, you can use the 300 method to speed things up a little. Now, rhythm. There are 3 main designations for rhythm: regular, irregularly irregular, or irregular with a pattern, or simply occasional irregularity. In regular rhythms, the same distance will be found between each subsequent R wave. That can be bradycardic, that can be tachycardic, or that can be normal. The way to verify that a rhythm is regular is to use the paper method. So you take a piece of paper like this and mark off 3 subsequent R waves. And then you take those marks and then you slide them from beat to beat. And if they line up, then you know that that's regular. If you were to do that same method for this tracing here, ignore these markings, you would see that they don't line up. And so you can call that irregular. Now in this pattern, you can see that there's an irregular beat here, but then it returns to a regular rhythm. And then you have another irregular beat, which is why we call this occasionally irregular or irregular. In an irregularly irregular beat, there is no pattern to the irregularity. These beats and these beats are easy to describe. Everything else can be labeled as irregular or occasionally irregular. The one that is important to know in this category is atrial fibrillation, and most other arrhythmias will fall in this category right here. The next step, after doing rate and rhythm, we want to check if a P wave is present. Starting in our rhythm down here, we can look at and see before every QRS, we have a distinct P wave. So we can say, yes, P waves are present. Atrial contractions here leading to ventricular contractions here. If we look at this rhythm, we might be tempted to call this a P wave. But if we were to look at a subsequent R wave, we wouldn't see that same marking. And if we were to look here, the chaos that happens before the QRS is not consistent with each beat. So we call this a chaotic isoelectric line with no distinct P waves, while this is a normal isoelectric line with distinct P waves. Importantly, when P waves are present, the morphology of each one will likely be the same, so that you know that the atrial contraction is originating from the same spot. After identifying whether P waves are present or not, we want to look at the QRS. So we start with rate, we start with rhythm, then you move on to the P waves, then you look to see whether the QRS complexes are wide or narrow. In a normal ECG, the QRS complexes will be narrow. Now the limit for how narrow they should be is below 120 milliseconds, or 3 boxes. In this particular example, QRS complex starts here and finishes here. That's 1.5 boxes, or 60 milliseconds. That is a normal QRS. In these two examples, you can tell that something's very different. The beginning of the contraction is here, and the end is here. 7 big boxes, that's a wide QRS. Here, this is about 6 big boxes. That too is a wide QRS. So we would distinguish this as being normal and these two as being abnormal. The difference here is where the signal originates. In a narrow QRS complex, the signal is originating somewhere in the atria or above the ventricles, passing through the Purkinje fibers and creating rapid conduction of electrical activity, which keeps the QRS complex narrow. In these sets of tracings, we know that the signal probably originates in the ventricles or in the myocytes, and that causes a slow conduction and a wide complex. This is VTAC, this is VFib, and this is what gives you this abnormal looking QRS complex. The next step that we would do in interpretation is the PR interval. So once you've done the rate, the rhythm, whether P waves are present, and whether the QRS is wide or narrow, you want to go back to your P wave and look at whether the PR interval is of a normal width and whether each P wave is associated with a QRS. So our normal P wave or PR interval is less than 200 milliseconds or less than 5 boxes. So we can clearly identify a P wave here and the beginning of the QRS complex there. So let's count. Here's the beginning. And you can automatically see that there's already 2 big boxes, which means 10 little boxes, and this is an extended PR interval. We can see that every P wave is associated with a QRS complex and that the space between them is the same, but it is consistently elongated. In this particular example, you may think that this is a normal PR interval because this is 4 small boxes, so below the 200 milliseconds that is required for a normal PR interval. But if you were to look at the subsequent P wave and QRS, you would see that you have 7 small boxes, so that's gotten a little bit longer. Then if you move to the next one, you would see about 8 small boxes. And then if you looked at the subsequent P wave, you would see no QRS here. So the lesson here is if you see a PR interval that's normal, make sure to look at other PR intervals because they may be extending in certain arrhythmias. And then finally, sometimes you'll see a variable PR interval. That looks normal, about 4 small boxes. And then you have a P wave with no QRS, a P wave with no QRS, and then a P wave that's about 200 milliseconds away from the QRS. And then a P wave with no QRS and a P wave with no QRS. So when identifying the PR interval, it's very important to look at multiple P waves and multiple QRSs to make your assessment of the PR interval. Our final step in interpretation is taking a look at the ST segment. First of all, what is it? It's a period of electrical quiet that's between ventricular depolarization and repolarization. The physiology of it is not that important. What's important to know is what changes in the ST segment signify. In short, depression signifies ischemia, elevation signifies infarction. If you see depression and elevation together on the same ECG, always defer to the elevation as it indicating infarction. Let's take a look at a couple of examples because there are different things that cause ST depression and ST elevation. At rest, you expect the ST segment to be close to the segment before it. Oftentimes with exercise, you'll get a certain degree of ST segment depression. So here is the isoelectric line, and here is a slight bit of depression. But importantly here, it's upsloping, and so probably not that dangerous. Another form of ST segment depression is downsloping ST depression. That is much more dangerous and indicative of ischemia that might result in infarction. And finally, a non-sloping ST depression or a flat ST depression is also indicative of imminent infarction. So what you want to do is find your ST segment, compare it to the isoelectric line before to identify how deep that depression is. To be safe, anytime you see ST depression, consider it ischemia until you can rule ischemia out and identify, go get yourself a consultant or someone else who can verify the ECG for you. Now, when it comes to elevation, this is what the tracing will look like. You go after the QRS, identify the segment immediately after the J point, and compare it to the isoelectric line, and you'll clearly see that elevation. So the two things in summary that you're looking for with your ST segment are depression, which most likely signifies ischemia, elevation, which signifies infarction, and if you see both elevation and depression in the same ECG, that probably means it's infarction. So what are the takeaways for our approach to ECGs? Always, always, always start with rate. You can do the 300 method, or you can do the 10-second method. The 300 method requires a regular rhythm. The 10-second method requires a rhythm strip. Next, look at your rhythm. It can be regular, it can be occasionally irregular, or it can be irregularly irregular. Many rhythms will fall under this category, and many rhythms will fall under this category. But if you see something that's irregularly irregular, the first thing you should be thinking is AFib. Next thing you're going to look for is P waves. What you want to ask yourself is, are they present? And are they in a 1-to-1 ratio with the QRS complex? If they are present, that's only half the battle. Then you want to know, is there proper conduction of the P wave into a QRS complex? If the answer to that is no, you're most likely dealing with an arrhythmia. Next thing you're looking at is the width of the QRS complex. It can be narrow, or it can be wide. A narrow complex indicates that the signal is coming from above the ventricles. And a wide complex indicates that's coming from within the ventricles. After that, you'd like to look at the PR interval. You'd like that to be below 200 milliseconds or 5 small boxes. Oh, apologies. Here for a narrow QRS, you want that to be below 120 milliseconds or less than 3 small boxes. Okay. If the PR interval is above 200, you're likely dealing with an AV node issue. Finally, you're looking at the ST segment. In depression, think ischemia. In elevation, think infarction. If you follow this sequence of steps with any ECG you get, you should often arrive at the correct diagnosis. As we post more videos throughout the semester, don't be afraid to pause those videos and come back to this tutorial if you ever forget how to go about any one of these steps. Thanks very much, and we'll talk to you soon.